Hello, today I'm going to be showing you this LED pyramid I built. It can be either powered by an internal battery or with USB power. So I'll just go ahead and plug it in because I don't want to drain the battery inside of it. So you can probably see it's doing a lot of different effects. I'll show them later on in better lighting. It can randomize through the different effects. On this side we have two buttons that can change the effect used. This button changes and cycles through the effects. So that's all on. This is turning on the LEDs for a high period of time. This is just randomizing all the LEDs. You can see the different effects used. And you can also change the speed at which they're produced by changing this button. So if I hold it down for a really quick period of time, you'll see it cycles through that effect really quickly. But if I hold it for a long period of time, it will do it really slowly. So that's how the basic control of it works. We have a 9-volt battery, an Arduino Pro Nano running at 5 volts, my input from USB, a switch to switch between using battery or external power, the two buttons right here with 10k ohm pull-up resistors, and right here we have 5 wires that go to this array of 20 LEDs. Since 5 times 4 is 20, we just need 5 pins to control the LEDs. Now because of the algorithm I'm using, I can just use a single resistor off of each of those pins. Each resistor here is 47 ohms, so that's a combined of just under 100 ohms, which drops from 5 volts to 3.3 volts that these LEDs require quite nicely. And you can also reprogram it with the FTDI breakout here, or not FTDI, UART. So it can be reprogrammable through this sort of interface. You can't just reprogram it through the USB connection though. You do have to open this up and reprogram it. So that just sits on there pretty nicely. Just clicks into place. It's nice and portable, nice and solid. The components don't rattle around a whole lot. I'll just talk about the algorithm that I'm currently using. The basic description is it's iterating through and continuously resetting the state, and each time I do an iteration I run a piece of code to change what the current state is. Now I store that state in an array of booleans or bytes, however you want to store the data, basically just on or off. So on each iteration it goes through and checks the state of each LED, and it basically just turns on the LED for that 1/12 of the time, or the 1/20th of the time that it's allowed to turn on. Now if I was to turn on 12 LEDs, it would still turn each LED on for 1/20th of the whole time it takes to do that. So that does dim the LEDs significantly. They do not look like they're running at a real 3.3 volts. So that's what goes on for most of these effects. But I mentioned this one before. where you can see that the LED is significantly brighter. The reason for this is I'm not using that algorithm for this effect. For this effect, I'm not cycling through each individual LED. This effect is simply saying to turn on one of those LEDs for that period of time. So the LED is constantly on, and it is being supplied a constant 3.3 volts. So it looks a lot brighter than otherwise. In fact, it sometimes looks brighter than even if you had all the LEDs on, which looks like that. So you can see that it is significantly brighter for just turning one on for a continuous period of time. I will post a link to the code that I'm using since I think it's pretty sophisticated. I'm not going to try and explain it here, so you can take a look at it. It'll be commented for the most part. You can try and understand it, implement it to your code if you want to take on a project like this. Drop me any questions you have if you want to partake in a project like this, because I'd be glad to help you out.